Assalamualaikum and hi. Today we would like to talk about the nuclear chemistry, the power and principle of the atomic nucleus. In this infographic, we highlight the most important concept in nuclear chemistry, what it is, how it works, and why it matters. Let's start with the basic. Nuclear chemistry is a special field in the chemistry that focuses on the structure on the atomic nuclei and how they change. These changes can release huge amounts of energy, and they are at the heart of nuclear power, medical imaging, and even space technology. Now, let's explore about radioactive decay. This is a process where unstable atoms become more stable by releasing energy in the form of radiation. There are different types of decay like alpha, beta, and gamma, and each one emits different particles or energy. A real-world example is uranium-238, which decays into thorium-234 by releasing an alpha particle. Next is nuclear fission. This is when a large, heavy nucleus like uranium-235 splits into two smaller nuclei. When it splits, it releases energy and more neutrons, which can cause a chain reaction. This is the principle behind nuclear power plants and atomic bombs.
Now let's move to nuclear fusion. Fusion is the opposite of fission. Instead of splitting, fusion combines two light nuclei like hydrogen atoms into one heavy nucleus such as helium. This process powers the sun and has the potential to become a clean energy source on Earth. Fusion releases more energy than fission, but it's harder to control with current technology. Then we have isotopes. Isotopes are atoms of the same element, but with different numbers of neutrons. Some of isotopes are stable, but others are radioactive. Radioisotopes are useful in many ways, using iodine-1 to treat thyroid. Now let's look at the diagrams in our infographic. On the left side, you can see fission. A neutron hits a uranium-235 nucleus, causing it to split and release energy and more neutrons. On the right is fusion. Two hydrogen isotopes, H2 and H3, combine to form helium and a neutron, again releasing energy.
Okay, now let's finish with a few important statistics. First, fission reactions release around 200 MeV of energy per uranium-235 atom. Second, fusion reactions produce about 17.6 MeV per reaction between H2 and H3. Uranium-238 has a half-life of 4.5 billion years. Today, about 10% of global electricity comes from nuclear power. The ITER fusion project in Europe is costing over 20 billion euros, showing how big the potential is. In conclusion, nuclear chemistry is powerful and complex. It plays a huge role in energy, medicine, and technology. We hope this infographic and our presentation help you understand the basics of nuclear reactions and why this topic is so important for the future. Thank you.